Hello everyone. So in the last video we saw we had a train R2 score of 0.820 and test R2 score of 0.6820 with a root mean square error of 0.663 with the tune parameters. So we are gonna be taking this model ahead with a better results to do some post-hoc analysis. So I have the saved model over here and I have already loaded that model, and what we are gonna do next is just to refresh our memories, evaluate our test data set. So the ask here is 0.682 for test, and this is the data set here, right? And for the train, this is the R2, and train data set with the actual and predicted values is this one over here. Now next what we are gonna do is plot a regression plot and plot between actual and residual values. So this is the code for that. So let me just break down the code for you. So in the first line of code here, we are creating a new figure with a size of 15 inches by 7 inches. So 15 inches wide and 7 inches height. Here this one creates a grid specification with one row and two columns. So we wanna plot two figures in one row and two columns. So first figure would be in the first column and the second figure in the second column. W space basically represents the horizontal, and H space represents the vertical space between plots. Next we are gonna be plotting a subplot along the row with index position 0 and column with the index position 0. So in that plot we will plot a scatter plot using scatter method of matplotlib between actual and predicted values. So these are the actual and predicted values. Color is cornflower blue, label is test, and these are other parameters. Next we also want to plot a regression line. For that I am using SNS dot regplot. So regplot method of the seaborn. Again this is the data set. So a regression line would be for the training data set. So this is the training data, and actual is on the x-axis and predicted values would be on the y-axis. Color is light coral, train label, and these are the other parameters. That's the size, this is the transparency, and this is the edge color. So these are just the labels, x and y labels. Anchor text. So I also want to print out r square values for the training and test set. So I am using add underscore artist method on the axis to plot the anchor text. Next this is just the legend, plt.legend. This is the location and size. So this was the first plot. The second plot would be for the residual plot, for the plot between actual values and residual values. This would be along index position 0 for the row and index position 1 for the column. And this is I'm just defining my actual and predicted values because I wanna subtract these x by y so that I have a residue. So this is the residue or absolute error. So we wanna plot between x and z. Similarly this is for test, and for train we have the same. A and b are the actual and predicted values, and c would be, or residue would be, a minus b. And then again using the scatter method of matplotlib we are plotting x, which is the actual value, and z, which is the residue. X along x-axis, this along y-axis. The color is same as I have given above. Label is test, and line width and all that things are the same. Again next scatter plot for the training data. X is the actual values here, x-axis. So along the x-axis we have a, which is the actual values of the training data, and c is the residue along the y. Light coral color, same, these are all the same things. This is just the labels and plotting. So you can also save this figure here. So let's run this. So this is the plot we have. As you can see, this is the regression plot. Blue ones are the test points, train points are these coral ones or maroon ones. This is the regression line, and since the test is little lower, so they are kind of spread out, but this is more concentrated towards the regression line for the training data. Similarly, for the second plot between actual and residual, you can see since we have a better R2 score for train, these are more concentrated towards the zero line. And for test data, the errors are kind of spread out. And next we are gonna be looking at what are these molecules with the highest and lowest error for the test set. So for that, let's print out the data set again. So this is the data, and I wanna have another column with the absolute error. So for that, I'm just subtracting this column with this column, and I wanna grab the absolute values. So let's have a look at our data set again. So this is the column, and now let's sort these values. Basically, I want the data points with the highest error at the top and the one with the lowest error at the bottom. For that, I'm using sort underscore values method on our data set, and I want to sort according to this column, and ascending is false. So, and second line of code, I'm just converting the first 8 molecules or smiles with the highest error into molecular objects, so that we can later view them using RDKit. Okay, so we have the test data set sorted, molecular objects in the form of a list for first 8 molecules, and then let's plot it using most grid image method of RDKit. So it would take an argument as a list of molecular objects that we wanna plot. 4 is the number of molecules per row which we wanna print out. Image size, legend would be the absolute error. So let's run this. So these are the molecules with the maximum error, and one potential reason for high error for these molecules could be that in the training data there aren't enough molecules with similar structures, so as a result they haven't really been trained well. As a result, the values are a little off, but that's what we have. Now next we wanna see the molecules with minimum error, so I'm grabbing the last 8 molecules here. These are the last 8 data points, and as you can see the absolute error is almost 0. So let's again convert these smile strings into molecular objects and then view them using RDKit. So these are the 8 molecules with the lowest error, almost 0 error, so they can be predicted with high accuracy. Now so this was all about these molecules. Now I wanna plot a distribution plot for the residue. So this was the absolute error. I wanna now have another column with the exact error along with minus and plus values. For that I'm just using subtracting actual and predicted values, and I'm creating another column called error. So let's run this first and see our data set. So this is the data set with error values, not the absolute but the exact error. Now we wanna plot a distribution plot for this column over here, and for that I'm just creating a figure object with size 7/6, and sns.histplot would take in argument as our data set, and then the name of the column which we wanna plot for the distribution plot. And let's run this. So KDE equal to true basically means we want to have this KDE line, and kernel density estimation line. And so this is the distribution plot, and as you can see it is pretty well distributed. Most of the molecules have error values between -1 and 1, so that's pretty good. And there are only few values with error lying between -1 and -2.5. Similarly, there are just few molecules with error values between 1 and 2.5. So you can do a lot more. So for this project I am just doing until this point, and in the next video we are gonna be talking about how we can use graph neural networks to train a classification problem. So basically we are going to be using the same data set, but we are going to be converting it into a classification problem. So and we are going to be seeing how we can use Pytorch geometric to train and test our data. So stay tuned for the next video, and that's it for now, and thank you for watching.